Hi everyone, my name is Lee Zhijian from University Tunku Abdul Rahman. Today, I would like to present my final year project with the title of Dual Elevator Control System. Okay, so this is the outline that I'm going to present in this video. So as we know that elevator is a very common equipment in our daily life, especially for the multi-storage buildings. It is a main equipment to transport the goods or people between the floors or decks of a building vertically. It is the work of human beings and keep them in a convenient way to carry heavy load without excessive usage of energy. Okay, so next I would like to give a quick introduction for my project. There are two types of microcontroller used in this project, which are AT89S52 microcontroller and Arduino Uno. For AT89S52 microcontroller, the programming language that I use is assembly language, and the microcontroller is basically used to control the basic operation for both elevators. For Arduino Uno, I have used C language to program it, and its main function is used to communicate with the RFID scanner. The aims and objectives of this project are stated in this slide. First is to implement a dual elevator control system by using two AT89S52 microcontrollers and one Arduino Uno. Second is to implement some safety features into the elevator system, such as the door sensor and also the RFID scanner. Third is to implement a pulley system on the elevator's moving mechanism. Next, I would like to introduce a system overview of this project. Okay, so this is the block diagram of the whole system. Firstly, there are two RFID scanners used in the system and connect to the Arduino Uno through serial peripheral interface. Next, each AT89S52 microcontroller is used to manage each elevator system respectively. As we can see that some of the features such as the floor sensor, door sensor, and some push button are the input of the AT89S52 microcontroller, while the DC motor and the servo motor will be the output of the AT89S52 microcontroller, which used to control the elevator cart and control the door respectively. Besides that, the three microcontrollers here are communicating with each other through UART communication interface. Since AT89S52 microcontroller has only one serial port, so a 2-to-1 data selector is used in this system. So here is the basic concept of the system. First, the system will check whether there is any operation or not. If yes, the system will identify the floor of the push button pressed by the user and it will turn on the DC motor. When the elevator cart reaches the respective floor, the door will open and check whether the door sensor sense anything. If no, close the door and repeat the operation again. In this slide, it shows the component that are used in some features, such as a couple of IR receiver and an IR transmitter are used as a door sensor, and MFRC522 and the MyFrame card are used as the RFID scanner, and a magnetic sensor is used as a floor sensor. So next, I would like to demonstrate how does the actual system works. First, I would like to introduce the structure of the elevator model. This is the counterweight of the elevator. Those metering are used to increase the weight of the counterweight so that the pulley system can operate smoothly. This is the elevator cart. The servo motor is attached at the top of the elevator cart by using a U-bracket which printed by 3D printer. The shaft of the servo motor is attached to the mechanism, which also created by using a 3D printer in order to control the door. The door sensor is attached at the door so that it can sense the object when the door is open in order to prevent the accident. This is the button that are located inside the elevator. We name them as inside button. The user can select the floor that they want to go by pressing those push buttons when they are inside the elevator. The second and third floor can only access when the user scans the respective access card. This is the button that are located outside the elevator. We name them as outside button. The user can call the elevator by pressing those buttons. The LED attached here shows the state of the button. If the button is pressed, it will light up. This is the magnetic sensor that is used to sense the position of the elevator cart. When the sensor senses the elevator cart, it will provide an output signal to the system. Next, the 7-segment display is used to display the actual position of the elevator cart. So that's all for the structure of the elevator model. Let's start the demonstrations. So here are the two elevator models that I built for my projects. On our right side is the first elevator system, while the left side is the second elevator system. Firstly, when we power on the system, The elevator card of the first elevator system is set at first floor, while the elevator card of the second system is set at third floor as default. When both of the elevator card is in steady state, no matter is at which floor, each of the system will have the highest priority to respond the function called by the user, where the function is came from the same floor that the elevator stay at. For example, when the third floor button is pressed, the second system will respond to it instead of first system, since the position of the second elevator is at third floor. It applies to the first system too. So, when the second floor outside button pressed now, the system has set the first elevator system has the highest priority to respond to the function called by the user where both elevator is in steady state. Since the elevator is working right now, the second system will respond to the next function called by the user. Since the second elevator is operating and moving downwards, the first system will in charge the response from the second and third floor. So we can see that the first system is responding to the third floor when the third outside button is pressed by the user. When the door is open and there is an object near to the sensor, the door will not close until the object is removed. Next, for the inside button, the user cannot access to second and third floor if they did not scan the respective access card. When the user scans the respective access card, the respective floor can be accessed. It is applied at both systems too. We can see that when the third floor access card is scanned, the system will respond to the third floor inside button when the user presses it. For the first floor inside button, it does not require the access card to access it, so the system can directly respond to it when it is pressed. From all the operations shown previously, we can see that the pulley system is operating in smooth conditions, and the whole system are functioning well. So that's all for the demonstrations. In this project, I have done some analysis based on the system. First is the analysis of each features. For each test, the number of samples taken is 30 samples. For a door sensor, it obtained 100% of accuracy during the test, which means that when there is an object near to the door sensor has provided correct output to the system. For FYP scanner, it has obtained an average accuracy of 93%, which is a very high accuracy during the test, which means that the user is successfully scanned the card when the access card is near to the scanner. For the flow sensor, the position of the elevator is successfully sensed by the magnetic sensor, no matter the elevator card is moving in the upward or downward directions. Furthermore, I have done the load analysis. The load analysis is important so that we can know that the current needed by the DC motor when the elevator is moving to prevent the short circuit on the system. So in this analysis, the weight of the counterweight is remained at 200 grams. From the graph, we can see that when the elevator is moving upward, the current used by the DC motor is directly proportional to the weight of the elevator card. On the other hand, when the elevator is moving downward, the current used by the DC motor is inversely proportional to the weight of the elevator card. Lastly, I have also done the analysis on the system reliability. The duration of the test is 16 minutes, which means that we keep on testing and provide a different set of input to the system, and there is no error occur during these 16 minutes. So the possible outcome of each state are recorded as shown in the table here. As a conclusion, the system worked reliably and functioning well, and the objectives of the project are achieved. I have successfully implemented a dual elevator control system by using two AT89S52 microcontrollers and one Arduino Uno. And I also successfully implemented some safety features into the elevator system, such as the door sensor and also the RFID scanner. And I also successfully implemented a pulley system on the elevator's moving mechanism as shown in the previous demonstration sections. So that's all for my presentation. Thank you.